and welcome to another edition of the Generative Edge. This is your host, Vyas, and I'm joined by my co-host,
Don. Hi, Don here, and I'm so excited to have Brandon and his team here. Brandon.
Hi, I've got half of my natural language processing and generative AI team here today. So we've got Kristýna, Ali, and Szilvia.
Hello, I'm Kristýna. I work usually on NLP and data science projects.
Hi, this is Ali. My specialty is on retrieval augmented generations, or RAGs.
Hi, I'm Szilvia. I'm AI engineer and data scientist.
So we have all the buffs around the table today, and I'm really excited about this particular topic because the idea of this session is really just for us to unpack some of the underlying technologies in a way that people understand them, really, and to make it obvious, maybe more visual to some. And maybe we're going to start with posing to you, Kristy, if that's okay. We talk about the anatomy of generative AI. You said you're an NLP expert, right? So how does NLP form part of that? And what is NLP? Let's start there. What is NLP?
Great question.
Great question, yeah. Well, simply put, NLP stands for natural language processing, and that basically means we're trying to help computers understand and use human language. And it has...
Can it help my wife understand my language? Just kidding.
And there are many direct use cases that we all see every day and use every day, even though we might not be aware of it. Like when you open your mailbox and you do not see all the spam messages, that's because all the spam emails were classified as spam. So someone had to, or not someone, a machine had to identify there are certain signs for this to be labeled as spam. Or Google Translation or other translation services for just like understanding text in other languages, that all comes through natural language processing. Other examples are all the different voice assistants like Siri and Alexa that many people use. And in order for them to turn on the light, they first have to understand what you're asking them.
Alexa's a great example. She basically runs my house. And maybe Brandon, to you. So these are some of the sort of typical interactions we have day to day. Like, what is a typical business example of how we use NLP?
Typical business examples. There are a lot. Probably the most popular one at the moment is information retrieval. So you have lots of documents or PowerPoints, proposals that you put together that pull on lots of different sources of information, and finding that information takes a lot of time. So it's really common now for us to get requests. Okay, can you build a search engine on top of all of my documents? Can you make it easier to extract that information? Or classification. So similar to the spam classification in email, you might have a customer support incident where somebody's creating a customer support incident ticket. They need it classified into one of 100 different categories, and building a model to put it into one of those categories and forward it to the appropriate team. That's another really common NLP example.
But these aren't new technologies, right?
No, they've been around for decades at this point.
I know, it's been around, but every time I speak to someone like executive, they'll ask, how does NLP really work? Can one of you actually simplify that for us? I mean, what exactly happens underneath?
Is it magic?
Is it a magic?
It is indeed magic.
Is it black magic?
So actually, in one of our other episodes, we've mentioned a Czech scientist who was the brother of Václav Havel, I believe, who created this like word embedding model. So we have to actually convert human language into numbers because computers don't speak human language, right? And he came up with this algorithm where if you learn the distribution of words, you just throw all the words at a model and it tries to learn the distribution of all of them and how often they occur together. You create a model that basically learns that distribution. So if you input something, you get another output that follows that distribution. And everything else has essentially been built on top of that for the past 20 years.
So I had this classic question from one of the customers saying that, let's say there's a word like bat, right? How does NLP really recognize whether it's the nocturnal creature bat, which I love, or I play cricket? Todd, you can relate to that. Indeed. How do I differentiate between a cricket bat and a nocturnal creature like the other bat?
Ooh, who wants to take an NER question, Kristýna?
Well, that's basically also because the the language models that we use for this, they are trained on loads of data. So they know that the word bat for the nocturnal creature appears in certain contexts, right? While the one for baseball appears in totally different ones. So based on the other words that appear around it, it can typically distinguish which of the bats you're talking about.
So you mentioned NER. Is that an example of NER at work? Can you... Named entity recognition.
Yes,
right?
named entity recognition.
Is that an example of NER at work within an NLP context?
It could be through a certain lens. Like typically when we talk about NER, we talk more about named entities really. So you would like look at, what company is this article about? Or what are the products mentioned here? So it's more about like really specific things that have a name, but it could be whatever you train your model on. If you want to search for dog breeds in a text, you totally can train a model to do that.
Mm-hmm.
Interesting.
And how mature is this technology? Because I go into a bank sometimes, start typing in a chatbot. I ask a certain question. More often than not, I get something which is not relevant to what I asked.
Yeah.
It's improving. I see that happening day in and day out. But where do you think it is right now?
NLP without generative AI looks different for sure than NLP with generative AI. So I don't know, Ali, do you want to take this question? How is generative AI better or slightly different than using traditional NLP methods to chat with people, for example?
Yep, sure. Let's start with this, that from my point of view, NLP is the toolbox that generative AI is using to smooth it out and generates the human-like languages. So you have this toolbox like the NER and other things that recognize the entities and other things. But in order to human to understand it, whenever you go to the bank and you want to ask something, you use that toolbox and expanded the capability of that toolbox using the GenAI. And what the GenAI is actually doing is built on the something that we call it as a transformers architectures that was introduced in 2017 by the Vaswani et al. And they revolutionized actually our understanding how the words connected to each other in the context. And then Google comes with their technology as a self-attention. All you need is attention. And that's why we understand that this bat, what does it mean here? Is it that bat or this bat? That's how the machines actually understand the context and which word exactly means there and what is referring to. So overall, GenAI is smoothing out the information using the toolbox from the NLP.
I would almost call it like a middleware where you have like a software layer like underneath, that's the NLP. Then you have the person or whoever is actually interacting with that system. And in the middle, you have something that's restructuring it and putting it into the format of natural language. So these like large language models are really good at taking something that probably is difficult to understand, putting it into human language and interacting with the customer.
That's an awesome way of describing that. Probably I'll actually ask you to explain that a little more for our viewers.
Okay, sure.
It's important for us to understand the underlying thing, because there's a difference between a good experience with an NLP and a great experience. And I'm sure all of you have actually encountered that. I've been on sites when the first question I ask, I know it's a bot. But there have been other sites, I know that, oh my gosh, this is probably Andrea speaking and probably not necessarily Andrea. Andrea is the system, right?
Yeah.
So how do you make that out? Which means that you need to build a system which is very relevant for the business. So in order to do that, I mean, if there are viewers listening to it, to understand how does it work and what are the core components if you need to split the anatomy, I think that would be a great input for our users.
Gotcha. Actually, Szilvia, do you want to take this question? So what are the pieces of, for example, ingesting a bunch of documents, processing that information, and turning it into something you can talk to?
Let's take a look at an example. For example, how you turn a PDF, a financial report, in a digestible format for generative AI. Practically, whenever you have a PDF, that's an image. You can use an OCR service to extract the textual data from this huge image, which still gets resulted in an unstructured data which you need to pre-process then and vectorize for generative AI to be able to process. After having the OCR results, still you can use the general data engineering methods to little bit structure the data, eliminate the unnecessary parts. But then whenever you consider that, okay, this is the final content, what I want to read, then you need to vectorize, turn the textual data to numbers. You need to vectorize the data that we call embedding as a process. So at the end, you will have numerical vectors that we can pass as a context to generative AI.
So I'm sitting here trying to visualize that in my mind, right? And what I'm hearing is exactly to your point.
Yeah.
It's like this middleman. It's kind of just this, to Ali's point, this layer that softens the response to the person that's querying or interfacing with it. But underlying, you have all of these things firing, right? NLP, Szilvia mentioned traditional engineering methods.
Yeah.
So there's a lot of stuff happening in the background, right? And generative AI is the kind of cream on the top, right? Which is really smoothing it, I think is the word you use, Ali, towards the person making the inquiry. Question maybe to you, if I may, because Vyas and I talk about this a lot, because we don't sleep well at night in general, but we talk about that. My kids are keeping me awake. But we talk about the mental model in terms of how you approach these things. Now, GenAI is all the hype. It's in every second conversation I have.
Don't we know it?
But to Szilvia's point, there's quite a lot happening in the background. And I'm just thinking of, you'll be using text extract and comprehend and all these typical services in AWS in order to get to the point where you can actually use some of the LLM models to do anything that I would interact with, right? So how do you approach this in reality? Like, what is the mental process, the thought process? There's a problem statement.
Yeah.
And everyone thinks GenAI is the Band-Aid to just put on top of the problem statement. It's magic. But to Szilvia's point, there's quite a lot happening in the background. So how do you go about thinking through this as experts in this field?
Without getting too technical, I'll say we rely a lot on like typical data science stuff like data evaluation and testing. There's so much testing that goes into this. And I mean, Szilvia can probably speak to this even more, but we did a lot of like data filtering. So out of these PDFs and stuff, you have a lot of information that isn't actually relevant. White space, table titles, footers, headers, page numbers, dashes, colored bars, all this other stuff that gets extracted with certain tools, and you have to do a lot of work to prepare it, clean it up, and make sure that it's clean for the use in what we were talking about, these like vectorized, semantic search engines that build up context to send to the large language model to generate a response. So that's probably the bulk of where the work goes is these typical data science things: data cleaning, data preparation, data evaluation, and then finally you get to the point where you can build the software on top of all of that.
Yeah, there might be also like quite a bit of work on data enrichment, which again would mix like classical NLP techniques like the entity extraction, where you can add like, okay, these are the entities talked about. But there can be also already use of GenAI. For example, now we're building a system where we need to search over vast quantity of tables, but tables have just numbers in them, right? Like number is always similar to another number. So it's very difficult to search over different tables and be able to find which is the most similar to your different one. So we use GenAI to actually say, hey, this is a table. Can you describe it to me in words, in human language, so that we have something which is more easy to search for later on when asking our questions.
One other use case, sorry, I just one more thing, which I think is a very cool use case. There was a request that came through that was like, can you take all of these handwritten documents from Polish doctors in the past 20 years and extract all of the text? And it turns out that with some languages you can do this, like English, Spanish, Chinese. Other languages, those models just don't exist because no one's ever trained them or they don't have enough training data. But it turns out that these large language models that have both text capabilities and image capabilities are able to do OCR, optical character recognition, on languages where commercially there was no ability to do that before.
Wow.
And I thought that was pretty cool. Yeah.
I believe that for mental model, we have three pillars there. One pillar is the data, how we get it extracted, do some manipulations. The middle pillar can be AI, that we do some data science. It could be AI models and other things. And the third pillar is the presentation, how we interact with the user at the end of the day. So these three pillars from the mental point for mental model, I would say it's much more cleaner. For example, if we use the AWS has this bedrock that has all these three pillars in one place. For data, you can do a ETL, you can get it from PDFs, you can clean it up, you can check the PII, it's the personal information you want to remove it or something. For processing, you have access to different LLM models. You have access to different data science tools from the Scikit or the NLP toolbox. And for presentation, again, you have the interface that you can use the chat agent over there to interact with the external user or your users in any way. So these three pillars can help you immediately with your that mental model, I would say.
Awesome.
Great.
I'll break this to test with a challenge to you all, right? So because
We love that.
it's always sometimes good to understand how it works internally, but I'll give you a question which I keep getting asked regularly by the C-suite, right? So how do I actually build a customer experience with models which you have where my policies change very often, right? So let's say if you had something which was already pre-trained, I think it's easy for you to get that. Here's an insurance company who perhaps changed their policy every 6 months. I know they don't do it, but let's say that's the scenario.
It's a really active company.
And if we need to do that, how can I rely on one model? How do you actually design such solutions? Is that something which you can actually talk through?
I think there's this common misconception that we do a lot of fine tuning or that we like train the large language models. And in reality, we almost never do that. And we almost usually recommend that no one touch the model weights. So there's a difference between fine tuning, which is where you take the model and you fundamentally change it. You train it on additional text data and it learns a new statistical distribution of those words, right? So that would be useful for something where you need it to only focus on information in like thousands of medical textbooks or something. But with policies, it's more like you're not training it on that data. You want it to grab that data from somewhere, especially because it's going to change later in 6 months, and then use that information to generate a response. Now, if that information changes, instead of changing the model or any of your architecture, all you need to do is change what's in your search database, right? So you might have, as Ali was talking about, these RAG systems, right? They're just document ingest and pre-processing. And then if you want to replace that entire search system with something else, with new data, then you can, and you don't have to even touch the model itself. And the model itself is more of a generalist thing. It's good at human language generally. And as long as you ground it with the appropriate information, then you get answers that are grounded in that reality.
And grounding is a term you use in this space, right?
Exactly, yeah. Because when people talk about hallucinations, you can ask questions of a generative model and it might come up with something random because it's not actually doing any logic. It's just generating probabilistic outputs, right? Yeah.
Oh.
And there's a saying, right? Hallucination is actually a feature and not a bug, because that's exactly why you're creating a generative AI system. And that's a common misconception, right? So, and also you talked about a terminology called RAG.
Yeah.
Yeah.
What is RAG?
What is RAG? I think it's important for...
Ali, you want to take this one?
I can help you.
Resident RAG expert.
Yeah, I would definitely get that one. So just before moving to the RAG, I just want to, because some people are confused here at the moment, why we are not retraining or training. There is some data science, general data science over there that we, for example, for classifiers, for any other models, we usually retrain things. And that's because the data is changing. We have a shifting model, shifting data. That makes sense. But what the LLM or large language models do is actually they are predicting the next token. Token can be, in a simple manner, could be the next word. So we are trained them in the hundreds and thousands, millions of documents. And it says that after, for example, I love my dog, to take a walk, right? Yeah, because we humans, as a human, we just have this mentality and we can get it. But for machines, that's what actually Brandon mentioned, is that statistically, They say that what is the next word is, and the highest probability is the take a walk. So that's how the LLM works. That's why we don't actually train it all the time, retraining it or fine-tuning it all the time, because we still want to stick to generate something that is like a human nature, not in the specific domain, but in general area. But when it comes to the updating a data or adding a data or new data, these models are frozen in time. They don't have access to the new information, but they are very good with the human language. That's what we call it as RAGs, retrieval augmented generation. That what it does, we have some knowledge base, and we connect this knowledge base to these LLMs. And what does it do? Is that it takes some knowledge from this knowledge base, some information that is required for the user's query, and give it to the LLM and says that based on this information, provide a human-like answer to the user, to the end user. So that's how all RAGs all about is how you can extract information, let's say that very proper information that you specifically need for that domain, and provide it to your LLM, and that LLM do the magic, smooth it out, and create that fantastic human-like conversation with the end user.
So can we give an example
Yeah.
of where that, is the insurance topic a good example of that?
Yeah, let's say that for insurance companies, they change policy all the time. For example, in the winter, they have specific policies. In the summer, they have other things, and they update their policies. And if the user comes in that, what is the latest policy on, I don't know, some accident? If you ask these questions, if your data is trained on the old data, it won't provide you with the latest data. But when you connect it with this knowledge center or knowledge base using the RAGs, it will go over there and look into the latest policies over there, extract those policies, says that, okay, these are the new policies. Based on these new policies, only this information, give it back to the user. And it says that, yeah, on last week, we have new policy for this accident, and you need to be aware about this point A, point B, and point C.
And Szilvia, how much work actually goes into building one of these? Because we've actually built one together.
Well, our specific system took more than 1 year to build, with a lot of experiment to find, let's say, how to narrow down the context that we want to serve as the piece of knowledge base to pass to generative AI. So that was the largest part of the overall work. And then how we can instruct GPT or the generative AI engine to retrieve the information what we want. So it's not just enough that I want the latest policy. I want the latest policy for the summer for ski accidents in Europe or in Asia or whatever. So how to instruct the best the generative AI model and what context to pass. They're the major tasks.
For example, on AWS has the service Business Queue, Amazon Business Queue, that if you have a specific general knowledge that you want to set, you just feed it with the data, and it has this process that smooths out the whole process, and you can get to the answer much faster. It's true that you can build it yourself, and it will be more customized and personalized. But if you want to something as a POC, and you want to go to the production with something that is really fast, you can use one of those Amazon services called Amazon Q that helps you on that matter.
I just wanted to go back to the question you originally asked. How come we have all these amazing GenAI models now, and still you go to your bank page and you start talking to a chatbot and it never answers the question you have? And it's exactly because, of course, you could just directly plug in a GenAI model, but then you have no control on the answers, really, right? And the bank doesn't want that. It would give you language-wise perfect answers, but it might be totally hallucinated and incorrect. Mm-hmm. If you want to have control over your responses, you need some middle layer, like a RAG system, which would really influence on what kind of context the answer is based. And to build that, it takes time and effort, and it's super complex. And that's why this is still not as perfect as it might be.
That's a great
awesome.
point. Yeah,
That's a great point. This brings a new question in my mind. If I were the C-suite or the decision maker of a company, how do I get started on this journey? And with your experience as one of the best team I've worked with, can you give some insights to our viewers so that they can start thinking about executing it the right way?
Yeah. I think everything at first boils down to validating the business case. So you could reinvent the wheel and you could make it better. Is it worth it?
Yeah, totally.
Probably not. So I think it's really important to, generally what we do is we come up with like a matrix of all the things that you do in a certain process. Let's say that you have a team that's writing these news summaries or something. So they sit down, they download the news articles, they write a summary, they put the summary into an Excel table, and then they send it somewhere. So there's you break the problem down into individual components, and you measure the amount of time and money spent at each one of those steps. Then you identify which one of those steps can actually be automated, which one of them is really good candidate for generative AI. And then we would price, like, how much would it cost to run a solution like that? How long would it take to develop? Then you can choose from there. Okay, these business use cases totally make sense to build. These ones are super complex and could be possible to build, but probably not a good investment right now. And then choose on those ones that you actually want to build out. And then, of course, the second part is that the people who are actually making the solution, they need input from the business team. So often it's not the case that you can just tell me how does this work and can you build it? It's more like, how does this work and can you build it? Also, here's my team that can tell you what their job is and what exactly goes into that process. Because us as like AI experts, we don't necessarily know what people in banking do or people in insurance do, but we do know that they work with documents and text and language all the time. And then lastly, probably the third pillar would be talent. So if you have an existing team of data scientists and software engineers, they can probably easily be upskilled. I don't know, Kristýna, in your experience, moving from...
Absolutely. I'm a data scientist that upskills to NLP, right? So if you're open to learning and if you have perhaps someone in the team who can guide you a bit in like making the important decisions or challenging certain parts of the code, then like data scientists, software developers, they can definitely upskill to use GenAI or NLP.
Okay, so what I'm hearing, let me just try and summarize this, is we have a framework that we use with our clients to assess the order and feasibility of the use cases they wish to implement. So you would need some specialist that has business knowledge to challenge, potentially some technical experts, right, in order to get down to the real use case that generates real business value. Right? At the same time, we need to understand, do we have the right data? Do we have the information needed?
Oh, for sure. Yeah.
Yeah.
It's often the case that some of these business processes, while the people that are doing it know it really well, it's not documented anywhere. So not only do they need to inform the people who are going to be building the solution what they do, they also kind of need to document it, and they need to put down in real terms, like, how does this process actually work and why? And even during that process, sometimes we advise our clients how to, document those processes. They realize that there are different steps that they could just completely remove, or that are duplicating work that's being done unnecessarily. So they kind of get two things. They get a solution and they get a better business process out of it, which is a win-win generally.
So in doing this assessment, it helps sort of prioritize the business value, right? At the same time, we're able to quite quickly assess what the impact would be in terms of finance. What would it cost to implement? How quickly could we move? I mean, you mentioned 2 days to implement a POC, which then moved into production and gave real quick business value, which is really cool. And Kristý, if I'm understanding you correctly, you're saying we can work with existing teams that we have. We've got existing data scientists within our companies, and a lot of our clients have really great experts in this space. You're saying the jump or step towards using some of the technologies we spoke about today is not such a huge jump, right? It's quite easy to upskill in this space.
If you have some guidance, I wouldn't do it like totally just from scratch, but yeah.
Sure. So with some basic guidance, you could move in this direction. So the barrier to entry is pretty low for existing teams in this space, which I think is really exciting. Yeah.
That's fantastic. Good to hear, because a lot of people think it's complex. If you haven't started your journey yet, this is the team to talk about the journey.
We'd love
and
to.
it's easy to get started.
And that's a great note to end on. Really, thank you for everyone's time. It's been an exciting conversation. And remember, to our listeners, generate responsibly.
Woo. Yeah.